Okay, I have a very interesting card challenge to share with you today. And the amazing thing is, despite the fact that the spectator believes they have quite an advantage in this challenge, in truth, you have over a 99% chance of winning in the end, okay? So let me explain how this will work. We'll play multiple rounds of this game. The player who wins the best out of 5 rounds wins the challenge. Now we'll start with 10 red cards and 10 black cards, and we'll have the cards face down, and then we'll thoroughly randomize these cards. Now this step is very, very important because the theoretical average that we're trying to achieve here, that will in the end be to our advantage, will only be attainable if we truly randomize the cards, or sufficiently randomize the cards, okay? So it is actually important that the cards be as mixed as possible, really, okay? So we'll gather them up, okay? And so how this will work is we're going to deal out the cards into piles of consecutive cards of the same color. And then in the end, we're going to count how many distinct piles we have. And if the number of piles dealt out is somewhere between 9 and 13, you as the performer win that round. If the number of piles dealt is between 2 and 8 or between 14 and 20, the spectator wins that round. But despite the fact that the spectator has so many more possible winning values, you in the end have better than a 99% chance of winning the best out of 5 rounds, and consequently winning the card challenge itself. Okay, so we've randomized the cards, I think fairly well. I hope so. We'll find out, I guess. So how this works is you just begin dealing. So that's a black. So if the next card is black, then I put it on top, and I keep doing that until I get a different color. Well, I actually got red, so I start a new pile. Okay, the red goes there, next red goes there, next one goes there, and then I go on to the third pile. Okay, since this one wasn't black, I go on to the next pile. This one is red, so I put it on top of the previous red. With a new color, I go to the next pile. That's also black, so you put it down. That's also black, you put it down, black. Okay, we've got a red, so we start dealing into the next pile. You got a black down here, a red, red, black, black. Now I got a red here, so we're kind of running out of space because of my reduced camera real estate here. Okay, so this one would go down next, and then an ace, which is black. Okay, so how many distinct piles do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have 11 piles, and 11 falls within the range 9 to 13. Okay, now I think I'll go ahead and change cameras so that we can see better what we're doing, and I'll bring over a little write-up, so that a little sheet of paper, so that we can keep track of who wins what. Okay, the performer will win if the number of distinct piles dealt out is between 9 and 13, and the spectator wins if it's any of these values. Well, if you notice, there's only 5, quote, winning values for us. There's almost triple that for the spectator. There's 14, okay? But we actually won the first one, right? We got 11, I believe. 11's in this range right here. Okay, so let's mix these really well here. So I'm just going to give them a mix without them going underneath the piece of paper there. Okay, and you can play along at home here. I mean, get out a deck, try this for yourself, and you'll discover the remarkable advantage that in the end you have, despite the appearance that you really should not have any advantage. If anything, you should have quite a disadvantage, actually, in this game. Okay, and I don't know if we mixed it well enough there. Sometimes a table wash isn't the best, because the cards just kind of, they don't fully clear each other. And so you just kind of move around this big mass of cards, but they actually don't change places to the degree that we would want for a random ordering of the cards. Okay, there we go. That's pretty good. Okay, so I'll put this off to the side here. Okay, so how it works is, so I got a black. Now I go on to the next color. Go on to the next color. Go on to the next color. Whoa! You know, since it's red and the previous one was red, we deal it there. Same thing here. Same thing here. Whoa! Check this out. What the heck? And then we go on to the next black. Here's the black. Black. Red. Black. 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 Red. Black. Black. Red. I'll put it over here. I think you can see it. Okay. So you just count up the piles. We have 3, 6, 9, 10. And guess what? Where's 10? 10 is in our range right here. So we just won the first 2 rounds. Okay, well, let's mix these up again. Okay. Now, for the mathematically curious out there, if you're wanting a pretty challenging result to try to verify or prove, the theoretical average for this game right here, where we have 10 red and 10 black, and we're dealing out the cards in the way that we are into piles of consecutive colored cards, the theoretical average for this is a dealing out of 11 piles, 11 distinct piles. Okay, and if you notice in my range here, 11 is in the middle, right? So 11 plus or minus 2 gives you 9 on the left, on the lower side, and 13 on the right. That's how I got this range here. Okay, so the theoretical average for this packet of 10 red and 10 black is 11 piles being dealt in the way that we're dealing them. And so from there, I just went 2 values above, 2 values below, and it ends up being sufficient that if you play this game and look for the best out of 5 rounds, you are almost guaranteed to win. It's over a 99% chance. Okay, so it's really high. Okay, so black, red, that's fine. Another black, very good. Oh, so the black would go there, black would go there. No, red, we transition to another color. Same thing there. Oh, same thing there. Same thing there. Oh, same color. New color. Same color. New color. New color. Maybe I'll put it over here. A new color. Same color. Same. New. Same. New color. And same color. Okay, how did we do? Well, we have 4 by 3. We got 12. So there's 12 distinct piles of cards of the same color. Well, that falls in our range here. Okay, it's getting close to the upper bound, but it's in our range. So we've won the first 3 out of 5. Technically, the whole thing would be over if we're going to say whoever wins the best out of 5 rounds wins the challenge. We've already won. Well, what I thought we would do is play a total of 10 rounds, just so you can see that you will not always win, and the spectator will see that too. Okay, that you're not guaranteed to win this. Okay, but you do have a tremendous advantage. That's kind of the point here. But there's a fairly decent chance that you'll lose an individual round, but there's a very high probability that you will win the best out of 5, and that's where that 99% plus comes in. Okay, so let's check it out here. So we have red. Okay, we go on to the next color, same color, same color, next new color, new color, new, same, new, same, new. Not new, sorry, same. Apologize if I'm saying same and new in the wrong way. Okay, that's a new color, same color. A new color now, same color, new color, and new color. So that's 4 by 3. So that's another 12. And so we win that one also. Okay. Okay, so let's mix these as well as we can. A good way to mix cards actually is to just toss them high up into the air if you have big space, and let them land randomly on the table or the floor, and then have them and then turn them face down so you're not looking at what they are, and then just mix them up. I'm really just doing my best to make sure that these cards are being thoroughly mixed. Okay, as you can see, it's a genuine attempt to try to mix the cards, because we actually need them to be well mixed for the laws of probability to be on our side, actually. Okay, so let's try this. So we got a red, okay, new color, same color, new color, new color, new color, okay, same color, new color, same color, same color, same color, new color, same color, same, new, new. Wow, we're really, boy, that 12 is really feeling pretty happy there, as a happy number there. So we got 12 again. There we go. You can see how close it's staying to the theoretical average of 11, though, if you think about it. Okay, staying very close to 11. Now, we haven't gone below 11 yet, but we will. I mean, you play it long enough, you will. Okay, so let me just mix these. Okay. Yeah, and you can do this with any number of cards. So just so you know, so if you do it with an equal number of red and blacks, what you do to get your kind of theoretical average for what to base your values on, you take the number of cards, divide by 2, add 1. So for 20 cards, divided by 2 is 10, add 1, we get our 11. Okay, so for a deck of 52 cards, you would take 52 divided by 2, which is 26, add 1, you get 27, actually. Okay. Okay, so I think this is pretty well mixed. So let's see how we did. We almost should have written down the numbers up above, just out of interest. Okay, same color, new color, same, new, same, new, new color, same color, new color, same color, same color, same color, same color, same color. Yeah, we're going to get one on the lower end. That's kind of fun. New color, new color, new color, same color, same color. Check that out. We got 9. We nailed the lower limit there. Wonderful. But we kept it within our range, right? That's the important thing. Okay. Okay, so let's mix again. We'll just do a few more. And then I'll let you play with this on your own. It's incredibly surprising for the spectator, because when they look at the comparison of 5 values, 5 winning values for you as the performer versus 14 for them, they do some kind of mental division or comparison of those numbers and think, oh man, the performer doesn't have much of a chance of doing well here. I really should clean up. Well, they won't, okay, as you are seeing here. Okay, so red, new color, new color, new color. We might get a big one here. Let's see. Same, no, maybe not. Same, new, same color, a new color, same color, same color, same color, new color, same color, same color, same color, same color, new color, same color. Check that out. We lost. Okay? What? Yeah. Now that sounds like I'm excited about it. I am actually, because the fact is, the spectator can win this from time to time. Okay? But among 5 rounds, you're almost guaranteed to win a majority. So this proves right here, the spectator can win at this. And in fact, they just did. Okay, so they got in their range of 8 is in their range. So that, okay, very good. Okay, so let's mix them again, and we'll, like I said, we'll just do, was it 3 more and call it good. Okay. And a lot of you are going to put it on double speed, and I would too if I were you. Okay. Okay, and I just hope I'm kind of mixing them truly well here. I'm trying to, but I just don't want to spend too long doing that. Okay, so we got black. So new color, a new color, same color, same, sorry. New, same, same, new, same, new, new, same, same, new, new, right? New, new, and new. Check that out. Check that out. So we got 13 here, right? 4 by 3, 12 plus 1. So we just hit the upper bound for our winning range, okay? But nonetheless, it's in our range, 9 to 13, just barely. Okay, so 2 more. Well, let's see if we can get the spectator to win at least 1 more, maybe even 2 more. That would be great, actually. Yeah, if you're going to play some kind of game of chance, and it just well, I should be doing these down, face down, I guess. If the spectator just never, ever, ever wins, then they're going to figure it's rigged, right? I mean, and it probably is, but this game is not rigged at all, okay? Just the laws of probability in action. Okay, so that's probably pretty good. Okay, I'm actually rooting for the spectator here. I don't know about you, but I am. Okay, so let's see how we did. I'm being OCD about my piece of paper here. Okay, so red. Okay, new color, new color, new color, same color, same color, new color, new color, same color, sorry, same color, new, same, same, new, same, new, same, new, new, same. Okay, so there we got 11. We hit the theoretical average, actually. We hit exactly 11. So apologies to the spectator there. They didn't win that one, but maybe this final one they will. Let's hope they do. Okay. Now, I suppose if you want to get brave, it's up to you, really. It would be fun to try this out in terms of some empirical experimentation. But if you want to, tighten up this range here. So maybe consider 10 to 12. Okay? So 10 to 12. Okay? And you may find that that's sufficiently close because the theoretical average is 11, so that's just 1 above and 1 below. My feeling is that's too tight of a range. You will not have a great advantage in winning the best out of 5. Okay. Now, I actually haven't tested that, so that's something you can play with. And if you're able to tighten the range, that's good, right? Because that gives the spectator 2 more values. So now you have essentially 3 values, 10, 11, 12, that's it. And all the other 16 values are the spectators, okay? So that's pretty sweet. Okay, so let's check this out here. See how we do. Okay. Okay, so red. Okay, new color. Same color. New. Same. Same. New. New, right? Same. New. Same. Same. New. Same. Same. New. Same. Same. New. New. Okay, 10 this time. Apologies. So we got 10 this time, which is within our range here. Okay, so we would win yet again. Okay, so I think we've done that. Yeah, we've done that 10 times. So maybe play with this yourself and try out the range 10 to 12 and see if you can get a sense of, okay, does that still guarantee a big enough advantage for you as the performer that you almost certainly will win the best out of 5 rounds. I just know it is the case that if we have 9 to 13 as our winning values, you have better than a 99% chance. So maybe that's too excessive. So maybe I need to relax that a little bit. So try that on your own and maybe report back in the comments. Try 10 to 12 and see how much that changes the dynamic of the wins and losses for the performer and the spectator. So anyway, I thought I'd share this with you. It's kind of a fun thing I thought of just recently. It is based on a principle regarding the distribution of red and black cards within a deck of cards, but it's a principle that generalizes to larger collections of equal numbers of red and black cards. Okay, and I've given you the theoretical average, right? It's the total number of cards divided by 2 plus 1. That's the theoretical average. And then the degree to which you deviate from that. So here it was 11 for the theoretical average. So if you want to go just 1 below and 1 above, test that out. I guess I was being a little more conservative. I went 2 below and 2 above because I knew that would be sufficient to just guarantee that we're going to win the best out of 5. So anyway, thank you for watching and have fun with that. And I think it's a principle that could be used in a lot of different settings, and I'll be giving some thought to that as to how to bring that into other card magic videos in the future. So thank you for watching.